In our last video, we introduced the principle of a complex number, complex meaning having more than one part, named as real and imaginary components. We use these complex numbers as ways to solve quadratic equations, and in chemistry, they are used to describe wave functions of particles in our theoretical considerations. To handle complex numbers in chemistry, we need to be sure that we are able to treat them with all the same operations that we would use with the real numbers that we've used previously. In essence, working with a complex number is very much like working with vectors. We will explore the geometry of the complex number further in a later video, but for now it's enough to see that there are two components to our complex number and they can be combined independently. If we have two complex numbers, z1 and z2, we can add them together by combining the real components together to get the real component of the result, and we combine the imaginary components to get the imaginary component of the result. The same can be done for subtraction of the two complex numbers as well. If we wish to multiply two complex numbers together, then we simply do the same process we did for expanding brackets. We multiply all the terms together in the manner we've always done. The only thing we now need to be aware of is that whenever we see I squared, we need to remember the definition of I, that is, I squared is equal to minus 1. In this case, z1 times z2 simplifies to 39 plus 2i. Dividing complex numbers involves an extra step, and for this we need to introduce a new concept, the complex conjugate z star. The complex conjugate is notated with z star and is defined such that a complex number multiplied by its complex conjugate will return an entirely real result. This sounds like a mouthful, but the method for creating a complex conjugate is very simple and we've already seen the principle in action. For a complex number, z1 equals 3 plus 4i, the complex conjugate is simply z1 star equal to 3 minus 4i. When we multiply these together, we get a structure that we've seen before. This is the same formulation for the quadratic difference of two squares. Multiplying this out, we see that the imaginary component cancels out in the multiplication, while the minus 16i squared becomes plus 16. The complex conjugate is used in the division of complex numbers as follows. We need to eliminate the imaginary component from the bottom of the fraction, as this allows us to express the overall result as a single real component and a single imaginary component. Dividing z1 by z2 means that we need to get rid of the imaginary component from the bottom of the fraction. This means we multiply the top and the bottom of the fraction by the complex conjugate with z2 star. Expanding out the brackets and combining relevant terms gives us a result which looks slightly untidy. However, it is a complex number, expressed solely as a single real component and a single imaginary component. There are other functions that we will apply to complex numbers also. However, we will address these as we encounter them. For now, however, we've shown how to add, subtract, multiply and divide complex numbers, as well as introduce the concept of the complex conjugate. In our next video, we start to explore further the geometry of complex numbers, as this will tie together a number of important concepts from our maths course. Please continue to leave comments if you have any questions or suggestions.